Hello everyone, and welcome back to HealthTech Explorers. And today we will talk about statistics basics and central tendency. When working with medical data, whether from clinical trials, patient surveys, or laboratory results, the sheer volume of information can be overwhelming. Analyzing each individual value is often impractical and inefficient. To understand what is typical in a dataset, we use statistical measures that summarize and interpret the information. Today, we'll explore the key measures of central tendency and variability and how they are applied in medicine. Measures of central tendency: mean, median, and mode. When dealing with large datasets in medicine, such as clinical trials, patient surveys, or laboratory results, it's often impractical to analyze individual values. Instead, we summarize the data using measures of central tendency. These measures allow us to represent an entire dataset with a single value, providing insights into the typical or central value of the data. Mean, or arithmetic average. The mean, often referred to as the average, is one of the simplest and most commonly used statistical measures. It is calculated by summing all the values and dividing by the total number of values. Example in medicine. In a study on virological failure among Tanzanian children, researchers calculated the mean age of 218 children as 10.6 years. Instead of listing all of 218 ages, the mean provides a single representative value. This approach simplifies data analysis and communication, as listing hundreds of individual numbers would be impractical and incomprehensible. Weighted mean: sometimes, certain values are more significant than others. For example, when studying patient outcomes, the data from patients with severe cases might be weighted more heavily than those with mild symptoms. Median. The median is the middle value of a dataset when arranged in order. It's particularly useful when the data contains outliers, as these can distort the mean. Example in medicine. In a study on HIV encephalopathy, researchers reported a median age of 64 months for affected children. If the data included outliers, for example, a few children much older or younger than the rest, the median would provide a more accurate representation of the typical case than the mean. Odd and even datasets. With an odd number of values, the median is the middle value. With an even number of values, the median is the average of the two middle values. Mode. The mode is the value that occurs most frequently in a dataset. It is especially relevant for categorical data, or when identifying the most common outcome. Example in medicine. In a survey measuring pain on a scale from 1, or no pain, to 10, or most pain, the mode might indicate the most common pain level reported by patients. If the mode is 4, it means most patients rated their pain as moderate, a critical insight for treatment planning. For categorical data, such as patient satisfaction levels, for example, satisfied, neutral, dissatisfied, the mode shows the most common category, helping identify trends in patient experiences. Dispersion. Understanding data variability. While central tendency measures give us a typical value, measures of dispersion tell us how much the data values vary. Range. The range is the difference between the highest and lowest values in the dataset. Example in medicine. A study on blood pressure variability might find a range of 90 millimeters of mercury, lowest, to 150 millimeters of mercury, highest, yielding a range of 60 millimeters of mercury. This tells us the extent of variation among patients. Standard deviation, or SD. Standard deviation quantifies how much individual data points deviate from the mean. Low SD values are close to the mean, indicating consistency. High SD values are spread out, indicating variability. Example in medicine. In monitoring glucose levels in diabetic patients, a low SD suggests stable glucose levels, reflecting effective treatment. A high SD might indicate significant fluctuations, requiring intervention. Why these metrics are crucial in medicine. Understanding population characteristics, mean, provides a snapshot of the average patient profile. Median, useful when data includes extreme values, such as in emergency care or rare diseases. Mode highlights the most common outcomes or responses, guiding resource allocation. Clinical decision making. Measures of central tendency help clinicians set reference ranges, for example, normal blood pressure or cholesterol levels. Dispersion metrics highlight the need for personalized treatment in cases of high variability. For instance, if the average heart rate in a study is 70 bpm with a low SD, most patients fall near this value. However, a high SD might indicate underlying health disparities among participants. In summary, measures of central tendency, mean, median, and mode help us understand the typical value in a dataset, while variability measures, such as range and standard deviation, show how spread out the data are. Together, these tools enable clinicians and researchers to analyze information more effectively, make informed clinical decisions, and tailor patient care. Mastering these concepts is essential for accurate and effective medical practice. Thanks for watching. If you liked the video, don't forget to give it a thumbs up and subscribe so you don't miss any future videos. See you next time.